Alright, so first getting started with this project, I had to remove the hard drive and then came to the task of removing the front fascia. Now the front fascia kind of snapped off pretty easily by just undoing some fasteners and snaps at either side at the end, and there were a few along the sides, but it mainly just popped off right away. The next step that I had to do was to remove the side panels, and the side panels are the parts that are the large plastic mesh pieces that cover basically the ends of the device. The mesh side covers have three large, rather huge plastic snaps on either side, and they're located next to those holes that do not go all the way through. They look like they are solid infilled with plastic material. You need to push in next to those on one of the holes that do go all the way through, as I discovered in my disassembly process. And this pressing in through those holes that are next to the ones that are infilled mark where the snaps are, and then that allows the side panel to come off. And once all 6 panels, 3 on each side of each side panel, are released, the whole thing will slide off. And it's the same process for either side. As you probably may have noticed, I used a Liebman fluffy duster in order to extract a lot of dust and dirt out of the machine where I exposed it when I removed the side panel and exposed the metal mesh inner cover. And the Liebman fluffy duster did a great job to pull a lot of that dirt right out of the holes with very little effort. So that last snap that I was struggling so much with in the video, I was not going in at a straight enough angle, so if you come in at a straighter angle than I was, then you'll have a much better experience. I think that was one of my bigger problems that I had with that last portion of that snap. And also, if you come in on the second row, you can have a much better access at the clip itself to pop that loose. So yeah, come in at the second row next to that last hole that has infill, and you'll have a much better experience. To disassemble the back side, there are 5 large snaps near the HDMI and the Ethernet port, and there are 2 additional snaps located on the right side near the power plug port. Now these are very large snaps. They require a lot of force, so I highly recommend you use something like a really cheap little precision screwdriver in order to jam enough pressure in there on those tabs. And do not be afraid to use the necessary force, because it does require a lot to make those things let go. As before, I continued to use the Liebman duster to get all the dust out of the machine. Cleans it out really nice and really quickly. Next is to remove all 6 of the very long, square chamfered, round-headed Tamper-Torx T10 screws that go all the way from the shiny metal side through routing holes through other components and screw directly into the plastic material on the other side. Once those are removed, the square metal box will be free of all the sides of the plastic chassis, and you'll be left with just the chassis. It's good to have several different bushes to organize your screws so that you don't lose them. The only thing holding the disk drive in place, once the top and the bottom panels have been removed, is a single strip of very durable aluminum with an adhesive backing on it. So it's basically like a company-made aluminum tape, sort of. So in order to get that off, I just used a knife to sort of pry it open, and I was careful not to rip it so I could reapply it later when I reassembled the entire build. To disassemble the disk drive from the Xbox 360, all I had to do was remove and unplug the micro 6-pin power plug that was in the back, along with a simple SATA interface plug. And that's pretty much all there is to it. Well, the Xbox 360 proved to be the weirdest machine that I'd ever taken apart before. The weirdest part about it was that random little heatsink that's just hanging off the GPU heatsink off of a little support bar, along with its associated randomly again placed heat pipe that goes up to it. It's just a really weird design in general. Now, I did think that it was very interesting and a very smart design to include that plastic shroud that's in the back of the system. And what that does is it basically routes all the air that the system fans are pulling out of the machine. It pulls that air through a stream that is directed over both the GPU and the CPU's respective heat sinks fins. Yeah, it delivers the most amount of cooling to those two components with only a couple fans. That's really pretty impressive cost-cutting engineering right there. Final step to get this taken apart is to unplug the PWM Fan controller header right there. Just be very careful with it. The front power button has a multi-layered assembly. It's a separate daughter board that's attached to the front of the frame, and the main button is covered by a plastic shroud. There are 3 screws that attach the daughter board to the system frame. Those screws are located to the left and to the right of the top portion of that little daughter board to either side of the plastic shroud. Now the third one is located underneath the plastic shroud. So you'll have to remove that white plastic square shroud in order to see it, and then you can remove it as you can see in the video. The X-clamps that hold the CPU and the GPU cooler assemblies to the motherboard are designed with a bowed design. That means that it presses in on the motherboard at the center, and then the feet on all 4 corners are bowed outward, and that outward bowing is what, once it's latched inward on the standoffs, it puts pressure on them and holds them out. And that basically latches the entire motherboard and the cooler assemblies together. And this is accomplished by latching onto the outer ring of the standoffs, and the CPU and GPU clamps have little half-moon shaped grabbing prongs, I should say, that grip into the ridge that's in-milled on the standoffs themselves. This design allows it to grab onto them fairly effectively, although it is very difficult I would say, extremely difficult to get them loose without breaking anything. And you do not want to put too much pressure on the motherboard itself, or you risk cracking or breaking the PCB of the motherboard itself, or one of the little micro-sized capacitors that are numerous on both sides of the motherboard as well. So extreme caution must be used in order to get these X clamps off. This process that you're seeing of me cleaning off the CPU and the CPU cooler took approximately an hour and 45 minutes of constant scrubbing. So obviously I cannot show you the entire process, but you're seeing a very fast forwarded version of the process. As I was reflecting back on how far we've come since the Xbox 360 days, especially back when this original Xbox 360 Elite was released, we've just come so far in computer hardware since that time. The processor that's used in this particular Xbox is called an IBM Xenon Processor with 3 cores. It has 90 nanometer lithography, 32 KB L1 cache, and 1024 KB or 1 megabyte L2 cache. And note that there's no L3 cache. Compare that with newer 2012 Ivy Bridge, which is in my current system that I'm using to edit this video on. It has 22 nanometer lithography and 4 cores with 8 threads of hyperthreading, compared to the newest 2016 Skylake, which has 14 nanometer lithography, which is also the same as the new 7th generation Kaby Lake, and up to 10 cores, 20 threads, with the i7 6950X, and 8 cores, 16 threads with the i7 5960X. We've just come so far in computer hardware since these old days. The GPU is an ATI Xenos with 232 million transistors. Compare that with the current generation Titan X Pascal with 11 billion transistors. 500 megahertz core clock seems very slow by today's standards, and compute power of only 240 gigaflops. Compare that with Titan X Pascal with 11.0 teraflops, over 46 times the performance. 16 texture filtering units, 1 for each of the 16x anisotropic filtering. Texture fill rate of 8 gigatexels per second, and DirectX 9.0 hardware support at the latest for the 360. Dedicated VRAM for the GPU in the Xbox 360 is only 10 megabytes of eDRAM, which utilizes an additional logic board with 192 parallel pixel processors for color, alpha composting, alpha blending, and most importantly, anti-aliasing. It was notably referred to as intelligent memory by Microsoft at the time. Provides 4 sample anti-aliasing at no cost to the other hardware, and that was the reason they went with it. As you can see, it's a very cost-cutting design, very low performance by today's standards, but back then it delivered the most beautiful experience that a console at least had ever given gamers. It's amazing to see just how far we've come. It's not shown in my video, however, I did use a standard household vacuum cleaner as part of my cleanup process for the fans. Now the vacuum cleaner, you have to be careful because it will spin up the fans pretty darn fast just because of its own suction. However, utilizing a Q-tip to break it free and the vacuum for suction force, I was able to clean out pretty much the fans like brand new. So I would highly recommend that method if you can do it. The little guide shroud that goes over the little front power board fits right on there with very little issue and very little effort. One last dust sweep of the airflow shroud on the inside and it's ready to be installed. And I was really happy how easy it drops in there. Just one little click right next to the fans. As always, when you're working with one of these machines, never forget how delicate, absolutely delicate, that eject button is on the disk drive. If that strip of plastic breaks, then you're out looking for a new part for your machine because there's no way to fix it, no way to glue it. Be very, very careful with it. Well, it was a lot of fun to film this project to fix the Xbox 360. As with all aging hardware, it takes work to keep it going. It was about 5.5 hours of footage filming this, and it took me about probably 17 hours or so in order to get it all edited properly. So hopefully I can get my workflow a little bit quicker, and so I can crank out some more videos. Look forward to more content coming out from Texel Hardware. Thank you.